Hi everyone, it's Perry from Math Together Canada. We're thrilled to introduce our special guest, Prince Zhang, a talented math student and problem solver who's here to walk us through the 2024 AMC 10A. In this first video, Prince will be tackling questions 1 to 10, explaining his reasoning and sharing tips for building strong foundations. Whether you're new to contests or just reviewing, this is a great place to start. Let's dive in with Prince and learn together.
Alright, so let's begin with problem 1 in the AMC 10A 2024. So here it says, what is the value of 9,901 times 101 minus 99 times 10,101? So one way you could do it is to use the distributive property to rewrite it in terms of powers of 10, like 1,000 or 10,000, which would make the computations easier. But I think that probably just bashing it out would be faster, so that's what we're going to do. So here, as we can see, the difference is 2. So our final answer will be A. Problem 2. So it states, a model used to estimate the time it will take to hike to the top of the mountain on a trail is of the form T equals AL plus BG, where A and B are constants, T is the time in minutes, L is the length of the trail in miles, and G is the altitude gain in feet. The model estimates that it will take 69 minutes to hike to the top if a trail is 1.5 miles long and ascends 800 feet, as well as if a trail is 1.2 miles long and ascends 1,100 feet. How many minutes does the model estimate it will take to hike to the top if the trail is 4.2 miles long and ascends 4,000 feet? So here, let's plug the values of L, G, and T into our equations. So here, let's work on this equation first. We'll move all variables to one side. And now let's plug this back into this equation. We could have picked any equation, but we just picked the first one because both are equally fine. Now let's plug the value of B back into A, so we get A equals now let's solve for T. So we'll plug the constants in. So we get t equals 246, so our answer will be B. Alright, and now let's move on to problem 3. It states, what is the sum of the digits of the smallest prime that can be written as a sum of 5 distinct primes? So there's only one even prime, which is 2. And since we're adding up 5 primes, if we include 2 in our sum, then the other 4 are all odd, which means that the sum will be even, which is impossible because no other primes are even. So therefore, our sum must only consist of odd primes. So let's start by trying out the 5 smallest odd primes. Now if we add this up, we get 39. And since 39 isn't a prime, we'll go to the next highest prime, which is 17. Now if we add this up, we get 43. And a quick check shows that 43 is indeed a prime. So we add up its digits, and our answer is B, 7. Alright, let's move on to problem 4. So it asks, the number 2024 is written as the sum of not necessarily distinct 2-digit numbers. What is the least number of 2-digit numbers needed to write the sum? So since we want the least number of 2-digit numbers used, let's maximize it by using 99 as many times as possible. If we divide 2024 by 99, we will get 20 with a remainder of 44. Now since 44 is also a 2-digit number, we can just add this on as our last number, having a total of 21 numbers, with the numbers being 20 99s and 144. So our final answer is B, 21. 5. What is the least value of n such that n factorial is a multiple of 2024? So immediately let's begin by prime factorizing 2024. And usually I find that whenever you're doing math contests in a certain year, it's always good to remember the prime factorization of that year's, so you don't have to do it during the contest. So now our largest prime factor is 23. So let's test out 23 factorial. 23 factorial obviously contains 11, since 11 is less than 23. And also, 2 to the power of 3 can be rewritten as 8. And since 8 is less than 23, 8 is also included in this. So our answer is D, 23. Now let's move on to problem 6. It states, what is the minimum number of successive swaps of adjacent letters in the string ABCDEF that are needed to change the string to FEDCBA? For example, 3 swaps are required to change ABC to CBA. So this is a well-known algorithm in coding called bubble sort, where you swap adjacent letters to attempt to get your final answer. So we'll use bubble sort. So since our first letter is F, let's begin by swapping F to the very front. Now this took 5 swaps because F needed to move through 5 letters to get here. Next, let's go for our second letter, E. This needed 4 swaps because E only had to move to the second position because it didn't have to go in front of F. Now let's repeat this process for all the letters. D required 3 swaps. C required 2. B required 1. Now, after swapping B to its correct position, there's only one position left for A, so we don't need to do any swaps for A. By adding these up, we get we get 15 as our final answer. So choice D is the correct choice. Now let's go to problem 7. The product of three integers is 60. What is the least positive sum of the three integers? So right away, we can think that since it doesn't specify positive integers, we can have two of these integers be negative, so that the product is still positive 60, but we minimize our sum. Now, since we still want the least possible positive sum, we can't use negative 60 as one of our numbers. So we can start trying some out, and we find that if we use 10, negative 6, and negative 1, we get 3, which is one of our answer choices. However, there is still one answer choice that's less than 3, so let's see if that's possible. Now, since 2 is even, it means that either we have 3 even numbers added up together, or 1 even and 2 odd. Now, since 60 equals 3 times 4 times 5, there's only 2 powers of 2 here. So we cannot have 3 even numbers. So we have to have 1 even and 2 odd. And now this even will either be 4 or negative 4. And now we can try out all the combinations. And unfortunately, none of them have a sum of 2. So our final answer is B. Problem 8. Amy, Bomani, Charlie, and Daria work in a chocolate factory. On Monday, Amy, Bomani, and Charlie started working at 1 p.m. and were able to pack 4, 3, and 3 packages respectively every 3 minutes. At some later time, Daria joined the group, and Daria was able to pack 5 packages every 4 minutes. Together, they finished packing 450 packages at exactly 2:45 p.m. At what time did Daria join the group? So currently, even though we don't know how long Daria worked for, we know exactly how long Amy, Bomani, and Charlie worked for, since they worked from 1 p.m. to 2:45. Now this is a span of 105 minutes. If we divide this by 3, we get 35. Which means that Amy packed 35 times 4 packages, Bomani packed 35 times 3 packages, and Charlie packed 35 times 3 packages. So Amy, Bomani, and Charlie together packed 350 packages, which means that Daria must have packed 100 packages. We know that she can pack 5 packages every 4 minutes. And so to pack 100 packages, we need 100 divided by 5 times 4 equals 80 minutes. If we subtract 80 minutes from 2:45, we get 125, which means that Daria joined at 1:25 p.m., which means that A is the correct answer. Now, problem 9. In how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people so that each team has 2 juniors and 2 seniors? Well, we know that each team has 2 juniors, which means that for the first team, there are 6 choose 2 ways to pick the juniors. For the second team, there are 4 choose 2, and for the last team, it's already set, and there's 2 choose 2 ways. If we multiply this out, we get 90. So there's 90 ways to pick the juniors. Similarly, there are also 6 choose 2, 4 choose 2, and 2 choose 2 ways to pick the seniors for the teams. If we multiply this together, we get 90 squared equals 8,100 ways in total. However, we must divide by the number of rearrangements of the teams. And since there are 3 teams, there are 3 factorial equals 6 different possible ways to rearrange the teams. And now finally, we get that there are 1,350 ways to choose the juniors and seniors to form 3 teams. So our answer is B. Finally, let's do problem 10. It says, consider the following operation. Given a positive integer n, if n is a multiple of 3, then you replace n divided by 3. If n is not a multiple of 3, then you replace n with n plus 10. For example, beginning with n equals 4, this procedure gives 4, 14, 24, 8, and so on and so on. Suppose you start with 100 as your value for n. What value results if you perform this operation exactly 100 times? So let's start by computing some terms and trying to find a pattern. So we start with 100. Now 100 is not divisible by 3, so we get 110, and then 120, 40, 50, 60, now we see that it repeats here. This is when we've applied 0 operation. This is 1 after 2. This repeats with a period of 3, which means that every 3 terms, the answer is the same. So for example, if the number of times we perform it is a multiple of 3, like 6 and 9, our final answer will be 20. And for 100, the remainder when divided by 3, or mod 3, is 1. So we can look for which numbers have a remainder of 1 when divided by 3. So that number is 7, 10, and so forth. So our answer is 30. And so C is the correct answer.
That wraps up part 1. Big thanks to Prince for breaking down the first 10 questions so clearly. If you enjoyed this and want to see more, stay tuned for part 2, where Prince will be tackling the next level of problems from the AMC 10A. And if you love math and want to contribute to a video, whether it's solving contest problems or explaining a cool concept, we'd love to feature you. Reach out at contact@mathtogether.ca and join us in spreading the joy of math.